So ये question है, a particle is moving in xy plane such that its velocity in x direction remains constant at 5 meter per second and its velocity in y direction varies with time as v is equal to 3t meter per second where t is time second. So इस केस में हमें ये चार चीज़ निकालनी है. First is speed of particle after time t. Okay, so we can say at time t is 10 seconds, the particle velocity in x direction let us call it as vx. अब दिया है हमें इन एक्स डायरेक्शन कांस्टेंट है, इट मीन्स इट इज नॉट टाइम डिपेंडेंट. सो vx कितना रहेगा हमारे पास 5 मीटर पर सेकेंड. बट इन y डायरेक्शन इट इज गिवन एज टाइम डिपेंडेंट. सो वी कैन राइट इन y डायरेक्शन, let us call that as vy, and it is given as 3t. So time is 10, we can say 3 into 10, that is equal to 30 meter per second. From here we can find out the magnitude. We can say magnitude of velocity, v is equal to vx square plus vy square and its square root. We put the values, we get v is equal to 5 square plus 30 square and its square root. So the final value of v, that is magnitude of velocity, v, it will be coming as 30.41 meter per second. In the b part, the direction of motion at that time. Okay, so it means we are going to find out what is the direction of motion at when time is equal to 10 seconds. So in the b part, and the important thing is that the direction of the motion will be same as the it will be in the direction of the instantaneous velocity. Okay, so we can say direction of the motion of the particle, direction of the motion of the particle will be along the instantaneous velocity. Which means we can directly find out, suppose it is given as theta, so theta will be equal to tangent inverse of y component divided by x component, and we already know the values. So tangent inverse 30 by 5, so theta is coming as tangent inverse of 6, and which is approximately equal to 80.53. Okay, so this is the direction. In the c part, we are going to find out acceleration of the particle at t is equal to 5 seconds as well as direction. Okay, so as the velocity is in x direction as well as y direction, similarly the acceleration also will be in the x direction and y direction, and we can find out their then magnitude. So in the c part, acceleration of the particle in x direction, let us call that ax, and that will be equal to derivative with respect to time of velocity Vx, and Vx is constant, that is 5, so Ax will be equal to 0. And we can say in y direction, let us call it as Ay, which is derivative of y component, and that is 3t, so this will equal derivative of 3t, and which will be coming as equal to 3. Now we can find out its magnitude. Okay, so we can say net acceleration which is A will be equal to ax square plus ay square. Ax square is 0, so we can say that net acceleration A will equal to 3 meter per second square. In the D part, we are supposed to find out displacement of particle at this instant. It means at time t5. So displacement of the particle in x direction will be, let us suppose it is given as x, it will be Vx multiplied by time t. Vx is 5, time is 5, so this will be equal to 25 meters. And in y direction, let us call it as y, and in y direction it is the equation of the velocity is time dependent, okay, that is 3t. So we can say that Vy is equal to 3t, or we can say this as derivative of y with respect to time t is equal to 3t. From here we can write dy is equal to 3t dt, and integrating with respect to respective interval, that is 0 to y, and from time is 0 to t, then we put the value of t, so we get this as y is equal to 3 by 2 t square, and at t is equal to 5, so at t is equal to 5 seconds, y will be equal to 3 by 2 into 5 square, and this will be coming as approximately 37.5 meters. Okay, so now the displacement is to be found with respect to the origin. So we can extend, we already know the x component as well as y component, so we can say that displacement of the particle starting point from particle starting from origin, and let us represent with respect to r vector is equal to x vector is 25 I plus y vector is 37.5 j, and we can find out its magnitude as well as angle. This will be coming as 45.07 at angle of 56.31. And the last part is we are supposed to find out equation of trajectory. Okay, so equation of trajectory means we are simply going to remove the time variable. So x coordinate is given as x which is equal to 5t, and y coordinate is y, and which is equal to 3 by 2 t square. So let us call this equation 1 and equation 2, eliminating t from 1 and 2, eliminating t from equation 1 and equation 2. Okay, so we can write this as, from equation 1 we are getting t is equal to x by 5. We put t is equal to x5 in second equation, so y will be equal to 3 by 2 t is whole square, and this will be coming equal to as 3 divided by 50 x square. So the equation of trajectory is represented as y is equal to 3 by 50 x square. So this is the equation of the trajectory. Okay, thank you.